Hello, I'm Bukola Joseph, and welcome to my channel. So, we are going to be talking about physics practical this year, 2025, what you should be expecting. Okay, I have the diagram on the board, okay, and I think the question that will be repeated is year 2009. If you have your past question, check out the practical physics question for the year 2009. Okay, I am predicting that is that experiment that will be coming out for question 1 physics practical 2025. Okay, now the apparatus for this experiment, like you can see on the board, you have 2 meter rules. The other meter rule you use to measure the height, okay, for the experiment you are performing. Then 3 retort stand is needed, okay, though we have 2 on this setup. Okay, this is the diagram if you have your past question and answer physics practical. Okay, and then you are given a mass, an unknown mass labeled M. Okay, and then it's going to be here. Let me read the question from the past question. You can see this is past question. Okay, so if you have your past question, but I will be reading it out for those who don't have the past question physics practical. Okay, you are provided with 2 meter rules and other necessary apparatus. 2, place one of the rules on a knife edge and determine its center of gravity. Mark this position with a piece of chalk. Okay, physics practical is something that you will always be given instruction. Okay, you'll be given instruction of how to perform the experiment step by step. Don't panic, just follow the step by step instruction and you see yourself doing the right thing. Okay, now you have been asked from this I to place one of the rules. You are given 2 meter rules, so you pick one of the meter rule and then find the center of gravity. Of course, okay, you know how to do that experiment. Okay, so once you find the C, usually the C should be between the range of 49.5 50.5. It shouldn't exceed that range. Okay, for a uniform meter rule, what I mean by uniform meter rule, it means that the edges of the meter rule are not chopped. Okay, it is uniform, it's not chopped. You know what I mean by chopped. Okay, so if it is a uniform meter rule, of course your CG should be 50 on the dot. That's 50.00 centimeter. Okay, but if it is not uniform, you shouldn't be getting 50. So the third instruction says read and record the mass MB of the meter rule written on the reverse side of it. Okay, so you'll be given a weighing balance to measure the meter rule. So once you measure it, you record it, okay, in 2 decimal places. And the fourth instruction says attach the mass 100 gram. You'll be given an 100 gram mass labeled M. Yes, you'll be seeing M on the mass. Okay, firmly to the rule AB at C. So you have found your center of gravity. So you would, this mass given to you, the unknown mass labeled M, you will be fixing it on whatever you have marked with chalk as your CG. Okay, and that's why you are seeing this M on the meter rule. That's the center of gravity for this particular ruler. Okay, so after you have done this, you've attached the mass on the meter on at the CG. Okay, the next instruction is suspend the meter rule by 2 parallel threads of length H is equal to 40 centimeters. So this is H, so it means you are expected to what, measure the rope. You know what I mean, rope. Okay, some people call it, is it thread or something, the thread they use for sewing shoes. Yes, that thread. Okay, you'll be given, but some don't have that thread. They use normal thread, the one for sewing clothes. So you will measure 40 centimeter with the other ruler that will be given to you. You measure 40 centimeter on both sides. Okay, 40 centimeter. So this is going to be your height, 40 centimeter. Okay, so each, of course, each at what, the 10 centimeter max. So it means this thing you have measured, this thread you've measured to be 40 centimeter, is going to be on 10 centimeter on this side. Okay, if this ruler is starting from 0 on this end, okay, you know it's going to be on 10 exactly. Then from this other end is going to be what, on 90. So if you remove 10 from 90, you have 10 centimeter. Are you following? So what is the next instruction saying? It says, ensure that the graduated face to the meter rule is facing upward. Okay, that point that you have taken note of, yes, this mask, the place you want to reach should be facing up, not side. Okay, not sideways, it should be facing up. Okay, where you'll be taking your reading, it should be up, facing up. Okay, so that's the next instruction. Then the next one, 6, says set the rule AB into a small angular oscillation above the vertical axis through its center of gravity. So you will be you are going to be oscillating this meter rule through the center of gravity. So you will tilt it a little bit, and then you have oscillation to and fro, to and fro. Okay, to and fro. It has to be to fro 1, to fro 2, to and fro 3. Okay, toward forward, toward forward. You count it: to fro 1, to fro 2, to fro 3, like that. That's how you count it. Then let's check out the next instruction. It said determine the time for 20 complete oscillation. So you are going to be doing this to and fro movement for 20 times. 20 times. Remember, a complete oscillation has to be to and fro. You don't count 1, 2, 3, 4. No. 1, 2, it goes here, it comes here. 1, it goes here, it comes back. 2. Okay, so the next instruction says evaluate the period t and t square. So you are going to be evaluating t on the table. So we have the d. It seems this d is going to be constant throughout the experiment, and so you have this. Okay, and then we have I know you've been wondering why 0.8, it has been converted to meters here. So 90, the distance between these two is actually 80. Okay, so we have the height 40. This is the time it took for the height 40. It took it 28 seconds. Of course, you are going to be given a stopwatch to measure the time. Okay, so and this is the reading. Okay, you ensure that you measure your time in at least 1 decimal place. Okay, even if it's 28 you are seeing on the stopwatch, don't record 28, record 28.0. Are you following? So let's check out the next instruction. It says read and record the value of D in meters. Okay, that is why we have this conversion. You know what you have on the meter is centimeter, and of course the distance between it is 80 centimeters. So converting 18 centimeters to meters, we have this 0.8 meters. Okay, so you have to follow instruction. If they say in meters, do it in meters. It has been specified. But if it weren't specified, we would have just measured it in centimeter. So we have that. Keeping D constant throughout the experiment. So it means this distance 80 centimeter will be kept throughout the experiment. It's going to be constant. Okay, we are not changing D. Okay, but they might decide to change D in your time. Okay, so please, you have to be open to understand whatever instruction that comes. Let's see. Keeping the constant throughout the experiment, repeat the procedure for other values of H is equal to 50, 60, 70, 80. Now that you have understood the process, you'll be asked to increase this height. This was 40. I think that was the first height. You will increase it to 50 on this end, increase to 50, of course, with the help of a meter rule. Then you increase to 60, to 70, to what? To 80. Okay? So, and then we have, what is the next instruction? It says, in each case, determine the corresponding value of what? T, big T. Of course, you know big T stands for what? Period. Then we have T squared. Okay, tabulate your reading. So your table of evaluation should contain every information you are seeing on the board. It should include height, D, T, big T, and T big squared big T. Okay. So and that is that for for this. I'm still Bukola Joseph, the physics enthusiast. Bye.